Okay, so now I'm going to show you guys integration by use substitution for definite integrals. Okay, quite a few steps. All right, here they are. You can pause the video, just take some time to read it. But use substitution really is just to make a complicated looking integral and turn it into an easier integral to solve. Otherwise, this is kind of a lot going on. Okay, so use substitution kind of clears that up. All right, but itself, the process itself has a lot of parts, a lot of steps, so it takes a lot of practice. Okay, first thing we're going to do is to factor out 6. Okay, we're going to let u be the most complicated part of the equation, which is going to be this part right here. Usually it is going to be the function inside another function. Okay, so the inside function. So when you do that, you take the derivative on both sides, end up with this. Okay, if you're going to turn this entire equation in terms of u, right, then the x and dx, the x and dx have to go away, have to be substituted. Okay, in that case, you're going to isolate the x dx for your du equation, so we're going to divide by -4 here. Okay, so here that's the same thing as saying -1/4 du equals x dx. Okay, so this is a good start. What's next also, especially for definite integrals, you have to change the limits of integration because right now they're in terms of x. Okay, I'm talking about these parts right here. All right, so that's what we're going to do. Doesn't have to be so long. Okay. And you're going to plug in your x values into the u equations we had here. All right, so in that case, when x equals 2, u equals 1. When x equals 0, u equals 9. Okay, and now we're ready to do all the substitution. So your new u equation is going to look like this. Everything is in terms of u. Here we go. Complete makeover. 1 x dx -1/4. I'm going to put -1/4 on the outside here. Okay, so after making all the substitution, it will look like this. There's no x values at all. Okay, I'm going to rewrite this equation so it's easier to take the integral. I'm going to factor out the -1/4 again. So 6 times -1/4 is -3/2. 1. I'm going to rewrite this like that. So you can see, you can compare it and see the difference between the two integral equations, but this is much easier to solve. Okay, let's do that. I'm going to raise the power. This is power rule at this point. So this is my first guess, but I'm going to have to throw on a -2 here to do the reverse of the power rule. So because there's no coefficients, the coefficient is 1 here. Okay. Yes, I believe this is the best guess. I'm set. Okay. So that I've already integrated that. Now I just need to plug in the values, use fundamental theorem of calculus. Through 3 times 2/3, which will just give me 2, and that's the correct answer. Okay, so I'm going to do the same thing, but much faster. Okay, so this is a different problem, but steps will be the same. Factor out the coefficient. We'll end up with x to the 10 minus x squared, 1/2 dx. Let u equal the complicated part. Take derivative on both sides. Okay. I noticed that there's an x and dx we have to isolate and completely substitute. So there we go. Divide by 2 x dx. I'm going to change the limits of integration. Don't forget to do that. At 10 minus 9, x equals 3, 10, so equals 1, equals 9. Okay, now we're ready to substitute. Fits 9 to 1. U to the 1/2 power du. Uh-oh, there's a negative 1/2 as well. Here. We're going to factor that out. So when I factor this out, I will get negative 3/10. Okay, so we're going to find the integrate. Oops. Okay, raise the power. Coefficient should be 2/3, no coefficient in front. I'm also going to factor this out and end up getting negative 1/5, looks like. Yep. I think I actually switched. Hold on a second. I accidentally switched the limits of regression. Make sure you don't do that, otherwise you get the wrong sign. So let me fix that right now. Okay. Back in business. It has power. Right now that's 3 squared. 1 minus 27. Okay. Keep working it out. 1 minus 27, that is going to be 26/5, which is the correct answer.